Yeah, good morning. And today we are going to compare the Gauss Seidel method as well as the Newton-Raphson method. So in recent years, there are a lot of troubles, issues in the power system. That is to maintain the power system stability. Power system stability is the main issue in the recent years. So normally you can go for any IEEE 6 bus system or 30 bus system or 20 bus system or above 30 bus system. So here, in order to maintain the voltage as constant, that is the main objective of power system stability. We have to maintain the voltage magnitude is always constant. So for that we are using the various fax devices like SVC, TCSC, so StatCam, etc. That is like a series compensation as well as shunt compensation. We are using the n number of various fax devices in the IEEE 30 bus system. It is to maintain the voltage stability. So here, by using the Gauss Seidel and Newton-Raphson method, which is used for the load flow analysis, also it is called power flow analysis. So here, there are four magnitudes will be there. So based on that, we are dividing the whether it's slack bus, so there is a slack bus, generate bus, or load bus. So here we have to determine by using that is called a iteration method. So by using the iteration method, here we have to determine the real power, reactive power, voltage, and the phase angle of voltage. So by using the Newton-Raphson as well as Gauss Seidel method. So these two methods is also called an iterative method, but there are some limitations and advantages will be there while comparing the Gauss Seidel and the Newton-Raphson method. So here they will discuss the comparison between the Gauss Seidel and the Newton-Raphson method in the optimal power flow, or it will be called as load flow analysis, or it will be called as a power flow analysis. So we will discuss.
Good morning everyone, I am Anna. So Newton-Raphson and Gauss Seidel are both iterative methods which are used to solve power flow equations in order to find bus voltage, angles and power injections. The bus terminal matrix updates voltage bus papers, which makes memory requirements low and coding straightforward for small characters. In contrast, Newton-Raphson method uses the Jacobian matrix and more complex matrix operation, which increases the computation storage but acceptable in modern software development.
Coming to speed for small sector, Gauss Seidel method is most of the implementations less demand and 4 to 5 iterations. In Gauss Jacobian method, it has 4 to 7 iterations, then more complex to the other iterations.
Gauss Seidel can struggle when near the voltage collapse condition or when it is highly loaded and it fails the converge. And Newton-Raphson is robust because it maintains the good accuracy and stability, and also it have a highly loaded system and IEEE test system like 57 bus network.
For classroom problems and small scale solving and simple studies, Gauss Seidel is used because it is easy to teach and implement, but whereas for real world cryptanalysis and large networks, engineers prefer to use Newton-Raphson because it is high speed and high accuracy.
In real world and the software angle, I have seen in student level simulation, I have seen MATLAB simulating and similar tools to handle Gauss Seidel for 5 to 6 buses system. 5 to 6 buses system, which helps to visualize the simulation skills. However, when the similar tools acts like an analyze to IEEE system, IEEE system with 100 of buses, Newton-Raphson becomes faster and better quality.
again convergence systems, we have a linear implementations in iteration like 4 to 7 iterations. Compared to the Gauss Seidel method, it is used to be a faster and high efficiency in power grid systems.
So in practice for lab experiments like MATLAB and other simulation tools, Gauss Seidel method is preferred.
So with the load flow analysis as well as also it is called a power flow analysis. So while comparing the Gauss Seidel as well as the Newton-Raphson, so the Newton-Raphson is more comfortable. So if it is the number of buses is above like 50 buses or 100 buses, so if you go for a high number of buses, the Newton-Raphson method is more efficient. It will be very fast and convergence rate is also very less. But if you go for a Gauss Seidel method, so it goes a number of iterations, like it may be 4th iteration, we will get the optimal power flow result in the either 4th iteration or 5th iteration or 6th iteration, etc. But in the Newton-Raphson, at lesser iteration, we can able to determine the optimal power flow or load flow analysis. Also, the Gauss Seidel, which can be used only for lesser number of buses, that is like the IEEE test bus system, like less than 10, it is more sufficient for Gauss Seidel. And if you go for above 10 buses, about 10 IEEE buses, it is better we have to go for Newton-Raphson method. So these two methods which can be tested by using the MATLAB tool or it may be ETAB. So the ETAB is the most powerful tool to analyze the power system stability or it may be harmonic analysis. So like that we can able to use the ETAB analysis. So either we can use the Gauss Seidel as well as Newton-Raphson, you can get the number of iterations. Okay, how many iterations we are running in order to get the optimal power flow. It goes n number of iterations. If the iterations increases, the time taken to get the output also it gets increases. So the time taken will be high. But if you go for NR method, it will be faster. So we can with a less number of iterations, we can be able to get the optimal power flow like real power, reactive power, the voltage magnitude as well as the phase angle. Any doubts?